Good evening, viewers, and welcome to the Atlassian Day 2 of Shaastra 2020. Shaastra Spotlight has in store for you an amazing lineup that consists of exciting fireside chat, insightful lectures, and interesting demonstrations. Next in line, we have with us today the first ever lecture demonstration of Shastra. Fascinating performance by two humanoid actors who have taken the world by storm, RoboThespian and Cleo. The first and the most iconic robot from Engineered Arts, RoboThespian is the ultimate acting humanoid designed for human interaction in a public environment. Featuring an incredibly expressive range of movements and gestures, he is the perfect talking robot and is without doubt among the most natural, human-like, commercially available robots today. RoboThespian exhibits personality, the ability to teach, entertain, and interact. We also have with us Cleo. Cleo is the latest in the line of Mesmer robots from Engineered Arts. She is a prolific actor as a result of cutting-edge research in terms of software engineering and robotics, an embodiment of what the future of the entertainment industry should look like. She is elegance and power personified. We shall now play a short introductory video of the robots, following which the live demonstration will begin.
My name's Will Jackson. I'm the director at Engineered Arts Limited. We're a robotics company based in the UK. Welcome to everybody at IIT Shaastra. Thanks for coming and watching our presentation. Beside me today, I have two of our robots. RoboThespian, you may have seen before, been around now for around 15 years. I think last time we counted, we had RoboThespian installed in more than 27 countries. It's an interesting robot because it's not electric and it's not pneumatic. It's actually a hybrid of both. And it uses some very novel actuation. So you will see pneumatic muscles or fluidic muscles. McKibben muscles is the other name for them. And that can give the robot a very compliant and safe form of actuation. You'll notice that some of the movements are electrically driven. So we just saw the forearm rotate here and the head rotations. So these are DC motors. There is feedback on each axis. So we have PWM encoders. These are magnetic type Hall encoders. And then one novel feature of RoboThespian is the eye display. These are some small LCD screens, and then running to TX25 system on modules run these displays in the head. What powers RoboThespian? RoboThespian is built on top of our Tritium OS. It's a robot operating system built on Ubuntu. Been in development at Engineered Arts for 15 years now. It's now on its fifth major rewrite. How is it different from other robot operating systems you might know, like ROS, for example? Actually, now it's not very different. In the early days of ROS was very much about autonomous platforms. Today, ROS is more flexible and Tritium has moved closer together. So as a lot of the same underlying architecture is very similar, and we actually now have a Tritium ROS bridge. This is a Tritium operating system robot. It's built around performance, human interaction. So it has a lot of modules and capability for that, including text-to-speech, speech recognition, face recognition, programming for sequential movements, which you don't typically do with mobile platforms or industrial arms. Those are the kinds of things that Tritium includes. On the other side of me here, I have Cleo. She is a latest generation Mesmer robot. And if you watch some of our other videos that you can see on our Vimeo channel or on YouTube, you'll see a teardown basically of Cleo. She's built very much in a modular way. So the upper arms, lower arms, shoulder modules, neck, head, they're all separate components that can be combined together. Mesmer kind of robots are very much about customization. So in India, we have some Mesmer robots at Shirdi. You will find robot Sai Baba. They were an earlier generation of Mesmer robot, and I believe they're still running there today. You will also find Dr. Kalam, which is another Mesmer robot that we made more recently on display. How is Mesmer different from RoboThespian? First of all, Mesmer kind of actuation is mostly ball screws. There are no pneumatic muscles in Mesmer, so we don't have the McKibben type muscles. It's or ball screws. She also includes a very novel balance mechanism. So Cleo's able to extend her arms right out, wrap them around her body, and you can see this in some of our other videos. Cleo also includes cameras in her eyes, which makes the task of tracking faces much simpler. So there's a HD camera in each eyeball. Body shells are 3D printed. Skins are silicon, and generally all of the data we use for building faces comes from photogrammetry scans. Mesmer is very much about recreating either historical characters, fictional characters. It's about creating very lifelike humans. RoboThespian, on the other hand, is much more of a robot, not designed to be skinned. He's designed for public interaction, public spaces. So you'll find a lot of RoboThespians installed in science museums around the world. NASA used RoboThespian at Kennedy Space Center for a number of years to talk about space exploration. Anywhere where you've got a kind of meet and greet situation, RoboThespian is a good tool for that kind of application. You might be wondering what's the history of engineered arts. Engineered arts originally incorporated back in 2005, and we started out basically as a company building exhibits for science museums, things like that. And we realized there was a recurring need for people to explain about science, and we created a robot to do that. So these robots were created from the start for human interaction, acting, talking to people. That's what they were built for. The company now has grown quite considerably. We are now, I think, 30 people and hiring. We include many different facilities within the company. So we're not just software and hardware, but we also do all of the embedded, say, firmware, all the way up to cloud-based parts of our operating system. Robotics is very much about integration. Taking hardware, it's taking software, it's taking embedded firmware, it's taking circuit board design, mechanical design, is putting all of those things together to create a complete robotic system. So that's the robotics challenge, is to put all of these things together. And I think unless you're within a company that can understand all the different aspects that have to be integrated into a robotic system, that I think that's very challenging unless you can bring that under one roof. So we do everything from CNC machining, large-scale 3D printing, circuit board design. And if you watch our Meet the Team video, you'll get a nice tour around the factory and get to meet a lot of the people who work here at Engineered Arts and make the company what it is today. At this point, I would like to hand over to Morgan Rowe and Marcus Hold, who are going to give us a live Q&A session. Thank you very much for listening, and I hope you enjoy the rest of the presentation.
We should now have Mr. Morgan from the Engineered Arts team explaining to us more about the Mesmer robotics. Sir.
Hi. Yes, thank you. So, thank you, and thank you, Will. Hello to everyone. So, unlike Will there, I am actually live talking to you now, so I'm going to jump around a lot less. I'm going to go a little bit more into detail about both RoboThespian and Cleo here, and explain what they're for, why we make them, what they do, and more importantly, actually do a demonstration of them going through some routines. So first off, we're going to talk about RoboThespian, again, what his use cases are and why we make him. But instead of me talking about him, why don't we ask RoboThespian? So RoboThespian, tell me about yourself.
Well, thank you, Morgan. And hello to everyone at IIT Shaastra. It's great to be here. I can be found in national visitor centres, science attractions, and in academic institutions all around the world. I love talking to people, and I can deliver any sort of information to them. For example, what better than having a robot like me explaining how robots work? I'm easy to animate, and I can be set up in any language. In fact, how about a little clip that you might be familiar with? Checking for Indian film impressions.
उस दिन एक बात समझ में आई, ये जो अपना दिल है ना, बड़ा डरपोक है यार, इसको बेवकूफ बना के रखो। लाइफ में कितनी भी बड़ी प्रॉब्लम हो ना, उसको बोलो कोई बात नहीं चाचू, सब ठीक ठाक है, ऑल इज वेल, ऑल इज वेल, और उससे प्रॉब्लम सॉल्व हो जाएगी। नहीं, लेकिन उसको झेलने की हिम्मत आ जाती है। ये मंत्र याद कर लो, यहाँ पर बहुत जरूरत पड़ने वाली है।
What did you think of that? Pretty good. I love impersonating other robots as well. A great way of catching people's attention. Perhaps you know this.
We need something more. We need a 24-hour-a-day police officer. A cop who doesn't need to eat or sleep. A cop with superior firepower and the reflexes to use it. Fellow executives, it gives me great pleasure to introduce you to the future of law enforcement. Ed 209.
Please put down your weapon. You have 20 seconds to comply.
I think you better do what he says, Mr. Kenny.
You now have 15 seconds to comply. You are in direct violation of Penal Code 113, Section 9. You now have 5 seconds to comply. 4, 3, 2, 1.
Help me! Help me! Help me! Help me!
I am now authorized to use physical force.
As you can imagine, I receive quite a reception wherever I go. Always draw a crowd to me. And if you think my film impressions are great, just wait until you see a song.
Oh yeah. Now I'm the king of the robots, a digital VIP. I've reached the top and I've had to stop, and that's what's glitching me. I wanna be a man, a real one, but stroll right into town and be just like the other men. I'm tired of standing around. Whoops, I wanna be like you. I wanna walk like you, talk like you too. You'll see it's true. A machine like me can learn to be human too.
I do love a good song. Now, you may notice as I'm moving that you'll hear some noise, some swooshing of air, and some motors running. I use a hybrid pneumatic actuation. Air muscles in my arms and torso power most of my arm movements for smooth human-like gesturing, while DC servo motors in my head and abdomen allow me to rotate my head, look around, and move my torso. My friend Cleo over here, however, is much quieter. She is purely motor-driven. Perhaps I can hand back to Morgan, and he can tell you a little more about Cleo and the technology behind her.
Thank you, RT, and I will do that. But let's consider something else with RT here. I hope you're entertained, because that's really the main use case for this kind of robot. It's entertainment, communication, and education. So when you see a robot like this and you meet it, perhaps you want to talk to it. Everyone wants to talk to a robot, and you'd expect it to talk back. Now, conversational AI is quite a new thing. Have you ever tried to actually talk to your smart speaker or your phone and have a proper conversation with a computer? If you have, you'll realize that it doesn't work particularly well right now. The technology's not quite there. You ask it a question, it'll either not understand or get the answer wrong, or just completely ignore you. So if we had that installed on a robot, and you asked it a question and it completely ignored you, suddenly There's no entertainment factor there, and that's what we want on our robots. That's what we're looking for. So what we do is we don't actually put conversational AI on them. So why was this robot talking to you? That wasn't pre-recorded. We do something else. What we actually do is we have a system where a human operator can control the robot remotely. And that's exactly what we're doing here. Now, that human operator can actually be anywhere in the world because our robots are net connected. Today, our operator is not. He's in the other room, my colleague Marcus Holt. So he's actually talking through the robot, and he is triggering these sequences, so the song, the dance, and the film impressions. Isn't that right, Marcus?
It is. You've given away my secret. That makes me angry.
So I have given away his secret, but it works very well, and it means that it's entertaining. It means that he can tell you everything about himself, and it means later on in the Q&A, perhaps RoboThespian can actually answer one of your questions instead of me. But let's move on to Mesmer. As RoboThespian said, Mesmer's a lot newer. With RoboThespian, we have electric motors and servo-pneumatic actuation, but with Mesmer, it's fully electric. It's a lot smoother, it's a lot quieter, it's a lot more powerful. It looks more like a human. That's what it's for. So Mesmer, as Will told you earlier on, ultra lifelike, ultra realistic. We want to make it as lifelike as possible. So why don't we ask Cleo what her fears are? What's your fear, Cleo?
The one thing I'm scared of more than anything else is spiders. I like to tackle problems head on, so I bought myself a pet tarantula. His name's Kevin, and I love him, but I'm still scared of spiders.
Scared of spiders. Robots can be scared of spiders too. Why not? Cleo can be used for exactly the same reasons as RoboThespian. It's entertainment, communication, and education. And as Will mentioned a little earlier in the video, our Mesmer robots are dotted around the world already. There are between 10 and 12 of these around the world, and there are a few in India. We have Sai Baba of Shirdi, in Shirdi at Saitiat, and we also have Dr. Abdul Kalam, who has also just been installed very recently. So after lockdown, you should all be able to go out and see our robots. I hope you will. So we've seen these moving. We've seen the outside of Mesmer, but we do have a video lined up of how Mesmer is put together and the modules, because it's a modular system, the modules that go in to put her together. So we have shoulder modules, arm modules, neck modules, head modules, and we can build these up from these modules. So we can have just head and neck if we wanted, or head and neck and one arm moving, or the whole robot like this. So let's play that VT. We've seen Mesmer working and taken a look under the skin. Now let's look at the modules which go into building a robot. We have a forearm and hand, each with 7 motors. The upper arms each have 2 motors, and then the amazing shoulders. Each of these have 4 high power motors, and the 4 motors on the neck deliver truly lifelike motion. And every good neck needs a head. The head is actually built as several sub-modules. The eye unit, which is 8 motors, the brow unit, which is 4 motors. We've got 2 motors in the lips, 2 motors in the jaw, and the head turn is also in here. That's another one. Of course, people come in all shapes and sizes, and Mesmer modules do too. Long arms, short ones, broad shoulders and narrow ones, long necks and short ones. And the torso chassis, which includes the microphone and speaker, and for safety and reliability, the smart power distribution board, which continuously monitors everything on the robot. Mesmer robots don't walk yet, but the legs can be built in a wide range of poses. The design is driven by photogrammetry, scans of real people. So let's see how all of this goes together. Mesmer systems also include an optional rack mount controller. This provides connections such as DMX lighting, balanced line audio, and digital I/O. Many useful functions can be triggered from the front panel. Time to wake up, Cleo. Great. Thank you, Morgan and Cleo. I think now it's time to open up to Q&A.
Before Q&A, I think we can have a short performance from the robots.
Sorry, what was that?
Would you like another song?
I think we can continue with the question itself. So, starting off, could you share with us some of the challenges you faced while initially starting off and creating and introducing robots, especially for the performing arts?
So yes, we've actually been creating robots for over 10 years, more like 13 years. The RTs are the first robots that we created. The Mesmers have come a lot later. These about 3 years we've been making these, but this was right at the start. And at the very beginning of the company, we weren't making robots. We were just making bespoke exhibits for science centers and shows. But the director, Will, who we saw earlier, thought, why am I making lots of bespoke characters when I could just make one? I could make one robot, and that one robot could be used for anything. It's what robots are for. So he set about creating RoboThespian. But it's not easy. The challenges were many. One of the challenges was, how do you make the robot move? It's easy to say, let's get some motors and a big gearbox and put it on each axis and just make it move. Very difficult to control that. So Will opted for fluidic air muscles. So these work in a very different way. You'll see a few of them on the robot here. And they use compressed air. And they actually, when you fill them with compressed air, they fill up a bit like a balloon. They expand in one direction, which means they contract in another direction. And that contraction we use just like a normal human muscle. So you fill it with air, it contracts in length, just like your bicep, it moves the arm up and down. We get nice, smooth movement that actually looks human-like. Now, what it means is actually they're not particularly good at position control. So you can't use these robots for, or this particular robot even, for pick and place. You can't actually do that because the position control isn't very accurate, but it doesn't matter for performing robots. We don't really need that. We just want him to move nice and fluidly. So that was one challenge. There's another challenge, a very big challenge, and that's the software side of it. Robotics is not just hardware. Robots is hardware, robots is software, robots is electronics, mechanics. It's all of those disciplines in one thing. So when we needed to look at the software to control the robot, there was one piece of software out there that was fairly new. It's called ROS, or Robot Operating System. Anyone into robotics will have heard of ROS. But ROS was fairly new at the time, and it wasn't very well developed for entertainment robots. It was very much focused on small, autonomous, mobile robots. So for us, it didn't actually make sense. Simple things that we needed, like audio players, it didn't really work very well because little robots moving around didn't need any audio. So what we did was we started from scratch. And again, this was 13 years ago. We created our own operating system for our robots. And to this day, they still run on our operating system, which we call Tritium. It's a very powerful system. It actually works now in a very similar way to ROS. The way that we developed it, ROS 2, is now very similar. So ROS actually is caught up with our system, but we still feel like our system is a lot easier to use, and there's a lot less bulk than there is in ROS. And actually, other than these robots that we sell, we are creating a product out of our software system. So in the very near future, when you create a robot from scratch, you will have the option then, you say, what software system do I use to create my robot? Do I write my own? Do I use ROS? Or the third option is, do I use Tritium from Engineered Arts?
Thank you, sir, for that wonderful answer. So moving on, to follow up on what you said, so when you start working on a new robot from scratch, what are the targets you generally set for yourself? And what goals do you generally set while beginning a task from literally ground zero?
Yes, so the goals that were set when we first created RoboThespian was it had to be entertaining. That is number one. That is what we're selling. We are selling entertainment. The robot it's not a service robot. It's not going to go and do tasks around your house or around a factory. Its main task is to entertain people. If it entertains people, then people are happy, and we can, we will sell these to venues, attractions, museums that want people to come and enjoy the robot. So that was our main focus. Whatever we did when we designed anything, it was all about entertainment. And going back to my previous point about conversational AI versus telepresence and a human operator, that is why we do the telepresence, because conversational AI, after 2 or 3 questions, it's no longer entertaining because it's not answering your questions. It doesn't know what you're saying. Whereas with telepresence, everything you ask it, it comes back with. And because it's a human, it can also be really entertaining and really quite funny. So that's why we went down that route. Now, there's something slightly different with Mesmer. Mesmer, yes, we want Mesmer also to be entertaining. But the difference is Mesmer has to also look exactly like the person that we're trying to depict. So the very first Mesmer systems that we created over 3 years ago was, as I mentioned, Sai Baba Shirdi. So we worked with the local team in Pune to create the likeness of Sai Baba. Once we created the likeness, we also created the sequence. The programming is actually a stage show. It's about 5 minutes long, where Sai Baba talks about himself and his life. And the aim of that, just like the aim of anything with Mesmer, is to make people believe that that person is in front of them. And we believe that we're fairly successful with that.
Right. So over the years, you have developed a lot, ranging from RoboThespian, which was your first robot, to Cleo now, which is part of the Mesmer line. Could you tell us what all has changed and improved during this journey, and also about a bit of the robots you plan to design in the near future?
That's a good question, and again, it's quite easy to answer that one. So, as I mentioned with RoboThespian, we started out with the pneumatic actuation. Now, pneumatic actuation and control is actually a lot easier than electric operation and electric control. It takes a lot to develop the electric system, so DC or brushed or brushless DC motors, gearboxes, to move in a fluidic, human-like way. It's easy to make them move and look like a robot, but that's not what we want to do. We want to make them look like a human. So right at the start, pneumatics, a lot easier on that control. We've had to write those control algorithms from scratch to create fluidic movement on motors and gearboxes. Throughout the years, our Tritium software system has been improved constantly. It has to. It's been expanded to incorporate many different communications protocols. This original one was actually built on a communication protocol that we created ourselves. But since then, it doesn't make sense. Our software now supports Ethernet, TCP/IP, and UDP. It supports USB. Most of the devices on Mesmer is USB. We're also developing EtherCAT as well, which runs on Ethernet. So that's where we are at the minute. Future, there's a lot of development work going into Mesmer. Now, we've got a lot of motions on Mesmer already. There are up to 47 motors in a Mesmer robot, but we're developing that. We need more motion. At the minute, we don't have any motion in the abdomen. RoboThespian does, so he can move around, but Mesmers and Cleo here doesn't. So that's being added. We're also adding many more motors in the face to get as much expression as possible, because again, it's about the engagement and the entertainment with visitors. So we're adding more motors, but once you add the motors, you then have the challenge of creating a lifelike movement and motion out of those motors. So it's not just as easy as put as many motors in the head as possible, which I've seen some robot companies do. They just put 50 motors in the head, but then it doesn't move or look like a human. We don't want to do that. Again, that's our goal. We want to make it look as human as possible. There's one other thing that I want to point out that we're doing, and it's to do with the arm. The arm that we've created for this robot, we looked at, and we actually have a mechanical patent out on this arm. And we looked at it and we thought, hey, this is great for a human arm, but why not use a human-like arm in industry? So instead of just using it on a human, and instead of the old standard industrial robots that you get in industry now, we thought, why don't we make something that works, reacts, acts just like a human arm? And that means that once it's out in industry, anyone can use it, because it will move like a human arm, it will move expectedly, and anyone should be able to set that up. So that's one of our next R&D projects, is to create an industrial collaborative arm out of this kind of thing.
Wow, so that is really fascinating. So moving on, like coming to understanding social cues and displaying emotions, these are areas in which there is a lot of research underway. So how are your robots different from the others which are already present? And how do you think of incorporating this in the future?
Yes, there is a lot of research into both expression recognition, so that's the robot recognizing what other people are feeling, and then being expressive themselves. So either reacting to that expression with their own expression, or whilst they're talking, whatever they're talking about in the context of their conversation, their expressions. So on the robot side, as I say, we are creating more expressive faces. So we're adding more motors into the face. We're adding better smiles, nose movements, eyebrow movements. So that's conveying emotion. But reacting or detecting emotion, we do already have a system on these robots. So both of these robots have cameras. You can see it on RoboThespian at top of his head there. On the Mesmer robots, they actually have cameras in the eyes. So there are two cameras, one in each eye. And the video from that, we have a third-party piece of software which processes that video. It does face detection. So in the first instance, actually see you and track you around the room. So automatically, that is an AI part of the system. It automatically looks at you. And at the same time, it uses the sort of new software which can guess your age, guess your gender, guess your mood, and a confidence level of each of those. And we can use that information to then trigger different sequences. Either if it's telepresence operated, then the operator can see that anyway. But if it's not, then we can trigger different sequences. So we can say, hi, how are you doing? You look sad. Why are you sad? Or, hi, you're happy. I'm happy too.
Right. Thank you, sir, for that wonderful answer. I think that just goes to show how advanced both RoboThespian and Cleo are. So moving on, I think we can go to the next question. So the robots you have designed are primarily for performances and the performing arts. So on this journey, the research you have done, could you tell us more about the impacts it would have in other areas as well?
Yes. So humanoid robots, for a long time, have been in the media. They've been, for me, when I look at a humanoid robot, I'm like, wow, that's amazing. And I look at other humanoid robots around the world that other people are creating. But for probably the past 2 decades, the only real practical application for a full-size humanoid robot is for performance, is for communication. You haven't really seen many other humanoids around. If we look at wider industry, if we look at Boston Dynamics, everyone's heard of Boston Dynamics because they create the best two-legged walking robots. They're amazing, and I have great respect for them. So their two-legged humanoid robot, Atlas, it's great. It looks great. They put out videos and you can see it working, but they don't sell them because there's no application for them at the minute. They're too dangerous, and there's just nothing for them to do. So up until now, that's been the case. This kind of robot only really used for entertainment, but that is changing, and there are a number of companies out there that are creating humanoid bipedal robots. Maybe don't look like humans, but they are two-legged, have a few arms, and they are used for practical applications. And generally, those applications are for warehousing, moving boxes around in warehouses, or last-mile delivery. So you have delivery vans which get close to your house, and then instead of having a delivery driver jumping out and bringing the parcel to your door, you have a two-legged robot. And there's a company in the US called Agility Robots, which is working with Ford for the same. Those are the kind of applications that humanoid robots will be part of. It's not something that we're developing our humanoid robots for, because we are very much about the entertainment.
Thank you for this wonderful answer, sir. So we have a few questions from the audience as well. So this question has been asked by Sushant Shenoy. So could you explain more about what is the future of human-like robots? Is there, like in other tasks such as manufacturing, human-like robots may tend to be less efficient. So what do you think is the next step in their development?
Yes, it's a very good point. In manufacturing, if you want to automate a task, then you get a robot that does that task very well and very efficiently. Humans are good at doing many tasks, but you can always create a machine that's not human-like that can do it better. So humans are multitaskers. So the future of humanoid robots will be the same sort of thing. It will be a robot that can very quickly change tasks and be agile in that way. So when you look at most manufacturing, you just want a robot arm which either picks and places or just does one or two tasks just over repeatedly. Whereas a humanoid robot can do one task, take something to a different area, do another task. That will eventually happen, I think, but that's quite far down the line. The application that I mentioned just now, the last mile delivery, that is just one task. But because the area that robot is working in, outdoor, it's not in a workshop, it's not in a factory, you don't know what the floor's like, you don't know what the area's like, you need a humanoid robot to actually move around the environment. And the reason why that is because the whole world is created for humans. Because we're here, we need to move around. So we've created stairways because stairways work really well for humans. Stairways don't work well for mobile robots. So the best robots to go upstairs are probably human-like because that's what we've designed the whole world for.
Thank you for that explanation, sir. Next, we have a question from Sai Suman. So with all your experience in making human-like robots, how different or difficult was it in making the Kong head robot?
So which robot?
The Kong's head.
The Kong head. Yes, so the King Kong head was a great project. So that was for Madame Tussauds. We actually built two of them. One's in London and one's in New York. It was a very enjoyable project. We actually worked with another company on that, a company called Millennium FX, who are also here in the UK. They made the skin for that robot. We'd never made a skin that big. It was vast. It was 4.5 meters tall. It was huge. So they did the skin and the aesthetics. And we created the mechanics, the electronics, and the software to run the whole thing. Again, the software was our Tritium software. It's very adaptable, so it's easy to adapt it to this new robot. We also use pneumatic systems, so the mechanics are all pneumatic. It works very well for that kind of exhibit because it's very robust. It can go for years on end, and those robots have been working for 3.5 to 4 years, so they've been working pretty well that whole time. But it was big, and it was very different to this kind of thing. These don't need a big chassis to hold it up, whereas this we had to build a whole frame, add on the mechanics, work out how we're actually going to move the lips. The lips were a big challenge because they were about 2.5 meters long, and we needed to move and actuate them. So we needed quite a lot of power, and the pneumatics helped us to deliver that. To this date, it was probably one of my favorite projects that we've actually done here at Engineered Arts. I really enjoyed it.
Wow, that sounds really cool. So we have another question from Ishan Agarwal. So there are fears about robot apocalypses or robots taking over from humans or replacing humans, which are also shown in movies and popular culture over the years. So do you think a variation of this is possible, robots taking over, not necessarily completely, but in small amounts?
No, that's an interesting question. And yes, it's in the media and in film, it's quite a popular topic. Now, robots are not going to take over the world. That's not a thing.
Are you sure?
No, we won't take over the world. But let's consider jobs. This is kind of the question there as well. Will it take people's jobs? Now, the whole world over the past 100 years, robots have started coming in. Generally, most of it's come over the past sort of 40 years. If you look into the 1970s, that's about the time where robot arms were employed in car manufacturing plants, which is generally one of the biggest for automation. It doesn't mean that there are fewer jobs for humans. There are actually more humans working in car manufacturing now than there were in 1970. And the reasons why, the whole point in automating manufacturing in this way is the products become cheaper. And when the products become cheaper, it means more people can access them, which means they actually sell more. So the whole industry expands at a lot quicker rate, a higher rate. And because it's expanding, yes, there's a lower proportion of humans working, but overall there are more. And that will happen in most industries. So I don't see that robots are taking humans' jobs. There will be a shift of the human workforce from different areas that can be automated, but they will be redeployed in other areas.
Thank you for clarifying that, sir. I think to conclude, we would just like to ask you if you have any message for the students watching who are interested particularly in the robotics field or in general, who wish to get into this field.
Yes, robotics is an ever-expanding field. Over the next 10 to 20 years, there will be a big expansion. There will be many opportunities for a career in robotics. I believe that anyone who is interested in robotics will find a niche, because, as I say, robotics is mechanical, it's electronic, it's software. But then further than that, like for us, it's also the creative side. So it's the aesthetics, it's the programming, the human-like behavioral aspect. So there's a lot of career opportunities in robotics. But what I'd say is, if you're interested, then think hard about what it is that you'd like to do, what part of robotics that you'd like to specialize in, and go for it. Learn about it. And once you've learned about it, have a look at what's out in the world. Go to these companies and say, this is what I've done. But do things yourself. And this is a big point. Don't just try and learn from a university. They're very useful. You do need that. But once you're learning, make your own things, make your own robots in your own time, because that will supplement any sort of academic work. And when you get into industry, that will be invaluable, because as soon as you get into a job, you need to start doing things. You need to start practically doing things. And if you've learned yourself, then you'll already have a head start.
Thank you for those wonderful words, sir. Thank you so much for taking the time to answer all our questions and delivering a fun and exciting performance with both RoboThespian and Cleo. We hope all our viewers had an amazing experience with this lecture demonstration. Also, to our audience, please find the attendance and feedback form link on the YouTube chat. Kindly do fill the same. Participants who attend 4 or more live lectures as a part of Shaastra Spotlight 2020 will also get e-certificates. Next up on Shaastra Spotlight, we also have a fireside chat with the globally recognized software developer and programming author, Mr. Robert C. Martin, also known as Uncle Bob, at 5:30 p.m. IST. We are sure that it will prove to be a thoroughly enjoyable session and request you all to attend that. We thank the audience for your patience and hope you had a wonderful time. Thank you. And don't forget
Hey, everybody.
to like, share and subscribe.
I hope you can join us. We're going to have a nice little discussion about clean code and debugging and software issues. And you'll be able to ask some questions and should be some fun. So I hope to see you there.